Hello learners, welcome to Constant Learners. In the previous video, we've discussed the first normal form. In today's video, we are going to get done with the second normal form. To understand second normal form, we must know what is normalization, what is first normal form, and what is partial dependency. All of these three concepts have been explained in three different videos that I will make sure to link in the description below. In today's video, we will first discuss what is second normal form, when do we say that a relation is in second normal form, and if a relation is not in second normal form, then how to transform a table into second normal form. In this video, we are going to take two different examples. First will be a general relation, and then we are going to take a more specific example, a specific table, and transform both of those into the second normal form, right? Let's get started. Now, there are two rules for a table or a relation to be in second normal form. The first and most important is the relation must be in first normal form. See, this is why it is important for you to know what is first normal form and when do we say that a relation is in first normal form. So, for a table to be in second normal form, the first and most important criteria is that the table should already be in first normal form. Now, let's assume that our table is already in first normal form. Then the second criteria will be that there should be no partial dependencies. Now, what are partial dependencies? See, if we have a composite candidate key. What is a composite candidate key? That means when a candidate key is made up of more than one attributes, right? That is two or more than two attributes. Then we say that it is a composite candidate key. Then the non-prime attributes must not be dependent on proper subsets of candidate keys. All of these words, if you're finding these difficult, please first go and watch the video on partial dependencies. You must know what are non-prime attributes, what are prime attributes, and what are the proper subsets of candidate keys, right? Now, let's say we have a relation R that is with the attributes A, B, C, D, and E. These are the five attributes in our relation or our table. And let's assume that the candidate key is A, B. Right? So this is a composite candidate key, and here also we're talking about composite candidate key. Composite candidate key because here we are using two attributes A and B to form the candidate key, right? Then the non-prime attributes. Now if this is the candidate key, then what will be the prime attributes? See, the attributes A and B are making the candidate key. Hence the prime attributes will be A and B, right? And the non-prime attributes will be all the attributes that were not used in forming the candidate key are the non-prime attributes. That is C, D, and E. Right? So the non-prime attributes must not be dependent on proper subsets of candidate keys. Right? Now in this case, since candidate key is AB, what are the proper subsets of this? A and B. Right? This will be the proper subsets of AB. If in case we had a 3 attribute candidate key, then what would be the proper subsets of this? AC, AD, and CD. Then A, C, and D. These would be the proper subsets of this key, right? In this case, this is only a 2 attribute candidate key. Hence, we are getting 2 proper subsets of this key. Now, what does this definition say? If we have a composite candidate key, then the non-prime attributes must not be dependent on proper subsets of candidate keys. That means if A determined C or A determined D or A determined E or B determined C, B determined D or B determined E, right? Now, in this case, on the left-hand side, we have A or B, right? So, the determinants are the proper subsets of candidate key. And on the right-hand side, we have the non-prime attributes, right? So, in this case, we say that partial dependency exists, right? So, this scenario should not be present. When this scenario is not present, we say that the table or the relation is in second normal form. The non-prime attributes must not be dependent on the proper subsets of the candidate key, right? When they are not dependent, when there are no partial dependencies, and when there is no partial dependency and the relation is in first normal form, then the relation is also in second normal form, right? Now we are talking about composite candidate key, right? Because in case, let's say we have a relation A, B, C, D, E. These are the attributes, right? And the candidate key is only D, right? Now in that case, we cannot have any proper subset of this candidate key. So all the other attributes will be dependent only on this attribute, right? So this is a single attribute and it is not a composite candidate key. Thus there is no chance of partial dependencies in this case, right? So we need to check the partial dependencies only in case of composite candidate keys, right? Then another thing is we're talking about candidate key, right? That means we're also talking about the primary key. You do not have to get confused. If further, I'm going to talk about primary keys in our tables, right? So you don't have to get confused that until now we were discussing about the candidate key. Now suddenly we are switching to the primary key. See, primary key is also determined from the candidate key itself, right? One of the candidate keys is selected as the primary key. So every time we're talking about the candidate key, we are also talking about the primary key, right? Now let's see, let's take two different examples. First one here we have a relation that is a table with attributes A, B, C, D and E, right? And the functional dependencies here are, so in this case, attributes AB are determining the attribute C. Then attributes AB are also determining the attribute E. And attribute B alone is determining the attribute D, right? So these are the functional dependencies. We've already discussed functional dependencies, so we're not getting into the details of all of this, right? Now, in this case, if we observe the functional dependencies carefully, we can see that attribute A and B, these two can determine all the other attributes, right? So let's take the attribute closure of AB. AB can determine themselves, so we get AB. AB can also determine C, B alone can determine D, and AB together can determine E, right? So now we have found out that AB is the candidate key, right? AB is our candidate key. Now in this case, the prime attributes will be A and B, right? And the non-prime attributes will be C, D and E, correct? Let's assume that our relation is already in first normal form. Alright. Now we need to check whether this is in second normal form or not. For that we need to check the partial dependencies. So partial dependency exists when a non-prime attribute is dependent on the proper subsets of the candidate key. That means out of C, D and E, if any attribute will be dependent on either A alone or B alone, then we will say that partial dependency is existing. Now let's check here. See, here it is given that C is dependent on AB, right? So AB is the candidate key, C is dependent on AB together. So this is not a case of partial dependency. This is full functional dependency, right? Then AB is determining E. That means this non-prime attribute E is dependent on both AB together, right? So AB together are also determining E. So this is also not partial dependency. But here B is determining D. So B alone is determining the attribute D. Now B is the proper subset of the candidate key and it is determining the non-prime attribute D. Hence in this case, partial dependency is existing, right? And when partial dependency exists, the table or the relation cannot be in second normal form. So now how do we transform this table into second normal form? See, when we discuss normalization as well as first normal form, we discussed that the easiest way is to split the table into two, right? But we need to understand how we are supposed to split the table into two or more than two tables, right? In the first normal form, we discussed different ways of splitting the table. Here also, for transforming the table into second normal form, we have a criteria, a very simple method which we can use to split the table, right? Now what happens is the candidate key A, B, this is our candidate key, right? So we are going to look at all the attributes that are being determined by the candidate key together. So here AB together is determining the attribute C and AB together is determining the attribute E, right? So the first table or the first relation that we will form will have the attributes AB, because of course they are the candidate keys, and C, D, right? So A, B, C, D. This will form a single table or a single relation, right? Then B will say that fine, you don't have anything to do with D, that's all right. I will go and live with D in a separate table. So we will get another table with just the two attributes, that is B and D. Because here in this case, partial dependency was existing. And when partial dependency exists, the table cannot be in second normal form, right? Now in this case, in this table, B alone will be the primary key and D will be dependent on B. So there will be no situation of partial dependency in this case, right? So how are we transforming the table into second normal form? By splitting it into two different tables, right? So this was our table wherein AB was the candidate key. Together they were determining C and E, right? So we have created another table, that is, let's say table 1, that has attributes A, B, C and E, right? And then there was partial dependency between B and D, right? So we've created another table, that is table 2, wherein we have only the two attributes B and D. Now let's take another real life example, right? Here we have a table wherein we have the student ID, name, subject, marks, professor and room number, right? Now in this case, student ID is 110, 111, 112, 3, 4 and so on. And these are the names of the students, Raj, Megha, Sneha. Now there are two Raj in this table and then we have Sarah. Now in the subject column, we have three subjects here, math, bio and chemistry, because Raj is studying all the three subjects. Sneha has taken math and chemistry. Sarah has taken chemistry and math, right? So now in this case, if you notice, we have multiple valued table, right? This attribute is a multi-valued attribute and thus this table is not in first normal form. So there's no question of this being in second normal form. When the table is not in first normal form, it can definitely not be in second normal form also. Now since there are three values here in the subject column, which marks am I talking about? Math, bio or chemistry? Which professor are we asking about? Math, bio or chemistry? And which room number? Math classroom number, bio classroom number or chemistry classroom number? So this becomes complicated in this case, right? So first we need to transform this table into first normal form. And to transform this table into first normal form, we need to create a single valued attribute or the attributes with atomic values, right? Now we have a table wherein we have the student ID that is repeating thrice because Raj has taken three different subjects, right? Then Sneha has two different subjects, math and chemistry, and Sarah also has two different subjects, chemistry and math, right? So now we have a table which is in first normal form because there are no multi-valued attributes, right? Now, this table is in first normal form, that's right. But is it in second normal form? For that, we need to check the partial dependencies, right? Now, let's discuss the dependencies here. That means which attribute is dependent on which other attribute, right? Now, if I tell you that, tell me the name of student with ID 111. So, we'll quickly look at 111 and say that it is Megha, right? 114 is Sarah, right? So, we understand that this name column is dependent on the student ID. If we have the student ID, we can immediately know the name of that particular student, right? So first functional dependency is that name is dependent on student ID. Now if I ask you which subject does Professor B teach? So we can immediately go to the subject, check the subject out, that is bio. So Professor B is teaching the subject bio. Professor C is teaching the subject chemistry. Professor M is teaching the subject math, right? So we can say that this subject is determining the professor. That means professor, attribute professor is dependent on the attribute subject, right? So this is the second functional dependency. So student ID is determining the name. I'm writing this in short, okay? And subject is determining the attribute professor, right? Now we know that math classes are being taken in room number 201, right? Here also we have math class and the room number is 201. Here also we have math class and the room number is 201, right? So we can say that subject is also determining room number, right? This is another functional dependency. Now we have the marks column. Now if I only tell you the subject name, can you tell me the marks? What are the marks in math? So in math, one student has got 35, another student has got 48, and third student has got 22. So it is not possible to get the single value with just the subject name, right? So we need two different attributes to identify the marks. That is student ID and subject, right? So we can say that student ID and subject together are determining the attribute marks, right? So these are all the functional dependencies here. Now if we find the attribute closure of this column, we will identify that student ID and subject, this is the primary key, or we can say the candidate key in this case, right? So our primary key is student ID and subject. So then prime attributes will also be student ID and subject. The attribute student ID and subject, these two attributes will be our prime attributes. Then the non-prime attributes will be name, marks, professor and room number. These four are the non-prime attributes, right? Now we already discussed that this table is in first normal form, right? We've transformed it into first normal form. But is it in second normal form? For that we need to check the partial dependencies. Now partial dependencies exist when non-prime attributes are dependent on the proper subset of candidate keys, right? The proper subsets of candidate keys in this case are student ID and subject. These are the two proper subsets of candidate key, right? Alright. So here in this case, student ID is determining the name. Now student ID is the proper subset of candidate key. So in this case, we can say that partial dependency is existing. Then subject is also the proper subset of candidate key, right? Again, it is determining a non-prime attribute. So here also partial dependency exists. Then again, subject is determining the room number. Room number is the non-prime attribute and subject is the proper subset of primary key or candidate key, right? So again, here also partial dependency exists. And in this case, both student ID and subject, which is a primary key itself, is determining marks. So in this case, partial dependency is not existing, right? But then there are three cases where partial dependency is existing, and thus this table is not in second normal form, right? Now, I've already told you how we can transform the table into second normal form by splitting it into more than one tables, right? Now, in this case, first we will take the primary key and the attribute that is dependent on the primary key. So, we have student ID, subject and marks. So, we will get one table with student ID, subject and marks. This will be one table, correct? Then the second table will be subject, professor and room number, because both professor and room number are dependent on the same attribute, the proper subset of candidate key, that is subject. So another table will be subject, professor and room number, correct? And finally the third table will be name and student ID, because it's only the name attribute that is dependent on the student ID, right? Now if we see, we have all the attributes are dependent on the primary key. See, marks are dependent on student ID and subject. And this is our primary key here. So there is no partial dependency in this case. Here the primary key is a single key, which is not a composite key. Hence, partial dependency is not existing in this case. Here also the primary key is the subject, and both professor and room number are dependent on the primary key. So again, there is no partial dependency in this case. Right? Now, all the tables are free of partial dependencies and all of the tables are in first normal form. Right? And thus, we can say that all of these relations are in second normal form. Right? I hope that this was clear. To be in second normal form, the relation must be in first normal form. There should be no partial dependencies, and this is applicable only for composite candidate keys or primary keys. I hope that the concept of second normal form was clear. If it was, please give this video a thumbs up, subscribe to the channel, and don't forget to share it with your friends. Stay tuned until next time. Thank you so much for watching.